You're listening to Data Science Leaders, the premier podcast for executives tackling the world's most important challenges using the power of machine learning. Let's dive in. How do you implement ML and AI projects in weeks instead of months? How do you drive adoption among extremely safety-conscious stakeholders where mistakes can be catastrophic? And what does responsible AI have to do with all of this? Today, we are going to find out, and I am joined by Dr. Alex Mannison, who leads data science for the Americas at International Flavors and Fragrances. You might not have heard of them, but I can pretty much guarantee that you've either been eating or wearing one of those products, if not in the last month, probably within even the last hour or the last day. Alex, thank you very much for joining us.
Thank you, Kiel. It's a pleasure to be here.
Alex, could you set the stage for us? I mean, what does data science look like at IFF? How is it similar or different to what it would look like at any other organization?
Yeah, sure. It's a great question because most of the companies that you hear about, the AI companies, they're really more in the consumer space, maybe insurance space, banking space. For manufacturing, we're still on the upswing, let's say, of converting to manufacturing 4.0 and utilizing AI in daily situations. But we at IFF, when we work with AI, we have multiple divisions. We have R&D, which has their own applications. Obviously, generative AI would be a clearly cool thing to design new flavors, design new fragrances. So lends to itself. But my team is within operations. We're concerned a lot with manufacturing, supply chain, procurement. So this is where AI has been kind of catching up to, let's say, what we call mainstream companies, right, where they are positioned right now. So we're developing a lot of these new products that are very targeted for some of the solutions that are different, let's say, from the consumer fields of consumer domain. So we're a little bit different in that regard.
Oh, it sounds like you have a lot more demanding, time-pressed stakeholders. So versus on a research project where, it can take a couple of months and it's fine. If it doesn't work out, there's no big loss. But it sounds like in your case, it's no, you really have to deliver for these stakeholders, because if you don't on the first time round, the likelihood that they're going to come back the next time round isn't quite so high. And presumably they're looking for results in a much shorter, quicker time horizon. Or am I exaggerating?
No, it's absolutely true. So the solutions that we develop are all for internal customers. And sometimes this is a very small user base, but still very significant returns. And yes, it's true. It's a very dynamic workplace. Things happen very fast. Priorities change very fast. It could be different products. It could be if we take too long to develop, let's say, a product for somebody, a digital product or analytical product, they will move on. They will try to do things by hand. They will find a workaround. They will lose interest very quickly. So the challenges can be very, very complex. And it's true that some projects can take years to fully develop from zero to final, fully blown product. So what we try to do to expedite the processes, we try to break it up into smaller pieces, smaller digestible chunks, targeting very specific problems. So we do root cause analysis we're not really delivering solutions. We're solving problems. We're not delivering products. The product is a byproduct of our work on solving a problem for end users. So if we can split up a complex problem into smaller parts and address one part at a time, it helps us in multiple ways. One is we started delivering value right away instead of waiting for a year to have a full application delivered. The second part was continue to build trust. So our end users, once they see the results, once we wow them with what AI is capable for, machine learning is capable for, our analytics are capable of, they start building us, they start looking for more, because we see that we make their life easier, right? That's our job, to make somebody else's life easy, to support them in some way. So they come to us. So what you did is great, but you know what? Instead of waiting for this big application, I also want you to solve another problem. Can you do that for me? So we start delivering, we get into this virtuous cycle where we deliver something very quick. And it could be, not necessarily fully productionalized. It could be a Jupyter notebook that somebody runs once a month, or a couple of weeks. Or it could be we generate one time a spreadsheet that does a job that helps them do their job 20, 30 times faster than they would have done otherwise. And they would go with this solution and say, you know what, this is good enough. Don't worry about the rest of it. I have another problem for you. Can you solve it for me? right? So we get into this cycle of delivering quick solutions and building one on top of another. And when we focus on one area and we do several projects in this, they naturally build up to a full application with different features and potentially multiple models or model improvements where model continues to develop as we build up applications, as we build up functionalities.
Well, I mean, it sounds like there are sort of interacting, self-reinforcing or reinforcing components to what you're describing here. It's the delivering value in stages means that you can keep your stakeholder more engaged because you're not going for long periods of time without them seeing results. And at the same time, by keeping them engaged, that also builds trust because they're now seeing the value, obviously, but they're also being pulled into the project in a much more direct fashion than, again, if you're going between long cycles. But it sounds like there is a, for lack of a better term, scrappiness to this. It doesn't have to look pretty as long as it solves the problem that's at hand. The end user, as you say, doesn't mind if it's a spreadsheet. They don't mind if it's presumably in a very simple application. It doesn't have to have bells and whistles and necessarily have a lot of end user design features on it because they're willing to work around that. These are tech savvy individuals who manage complex processes. If they have to jump a couple of hoops in order to get this to work in the way that they want to do it, it sounds like they're perfectly willing to do that.
Yes, absolutely. And then there is an expectation. We don't leave our end users. So if they say, yeah, we want this, better functionality, more pretty or something easier, obviously we work with them. And to be frank, I think one of the biggest reasons for our success is because we work so closely with our end users on solving very specific problems. Our end users, the people who are delivering these products they are part of the development team. So when we have our sprints or we have our meetings or biweekly reports, they are part of the team that was not only on the receiving end of the progress, they participated in that progress by providing feedback for what we do or providing domain expertise, explaining some of the things like how we can generate better features for our models. So they are very, very much integrated into the development team. They are really part of it. And I think it's a key to our success internally. I think all projects where we've been very successful were the ones where we worked very, very closely with end users. And there were some where we had very sophisticated models that had a lot of potential, but the end users were not consulted early enough. The adoption was a huge struggle.
Oh, yes. I mean, I struggle to think of any company or team that I've spoken with who hasn't been really striving to be as close to the end users as possible and to work closely with them. But it's an entirely different story in terms of actually achieving that. I'm wondering whether or not there's actually something which is different about your end users, that they are more data savvy and technically savvy than you would see in if you were just to take a random use case. And so because they're more data savvy, they live and breathe with this, it is easier for them to participate. It's easier for them to understand what's going on. It's easier for them to actually learn, and they probably want to learn about these methods in a way that, your average business user, say from accounting or from legal or a doctor, would love to conceptually, but they're not actually used to working with data and familiar with the ways in which can go wrong. Or again, is that not the case? And actually, no, we have to bring them along on the education side. And, they come from a whole range of different backgrounds. And occasionally, yes, we get lucky and they actually really understand this already. But for plenty of these other ones, we got to bring them along for the ride.
I think it's the latter. It's a mixture. So we work with analysts very often within their domains, like analysts within procurement, analysts within supply chain. So they're very used to working with data sets and numbers and doing analytics. So they are familiar. And also on the other hand, for manufacturing specifically, we work with process engineers if we're building models for, let's say, predictive process control, for chemical process control, right? They are also familiar with data, right? Not necessarily, they might not, some might actually know a little bit of machine learning, some might not, but they're familiar with data. But then on the other hand, we work on some use cases where people have almost, no interactions with data at all. I mean, you're a regular person like off the street. So like operators of the equipment, which know their chemical process, but they don't deal with a lot of data, or they don't even use, we worked on some use cases where people were still using pen and paper to record stuff, right? So we have a wide range of users. And very often, even the ones who are data more or less savvy, we still have to educate them. And this is where this iterative process of doing small things for them first, it really helps because they do start understanding. And As an example, one of the first use cases when I started at IFF, we built an entity resolution system, which was very successful because we worked so closely with our procurement partners. And the process took a while. And part of the process was for the procurement team to label the data, labeling for classification. So we successfully completed the project and it was in production for years. And then they came back to us years later and said, you know what? We remember what you did for us before. Can you do something similar, but in a different area? So we kind of already finished that. The project was done, we moved on. And then they came back to us and they said, we have this opportunity. You come help.
Well, I mean, that is the surest form of measure of success is when they come back and they want you to do it again.
Yeah.
Could you tell us a little bit more about that use case? So this is one where you're trying to making it easier to go between different procurement contracts because you are able to extract those entities. And now if you're searching for a particular contract, you're now able to get the full list of contracts that would actually have that entity. Or what are the ways that they use that data?
Yeah. So we have, as a company, we've over the years, we have grown a lot, and some of it was through mergers and acquisitions. And every company that we have merged with and acquired, they had their own systems for maintaining like vendor information or customer information, obviously. So we have a lot of these systems floating around legacy. And while there are consolidation efforts to bring it all together, you have to harmonize. So you have to resolve which entities across all of these databases really match. And on top of it, there is a complexity because match means different things to different people. So a person from finance might define a definition of match for them would be different from a person from procurement or somebody else. So the system that we built was specifically for procurement to try to recognize on multiple levels. So not just to recognize entities, but also hierarchy of these entities, because companies have divisions that might have different legal entities and they might have subsidiaries and so on. So we also built a hierarchy for them. So we built a solution that would harmonize across all of our databases in like MTM pass-through style. So we basically build a unique set of new IDs. We didn't change anything in the original systems, but we built a new unique set of IDs that would identify, point all the records to the same, that's supposed to be in the same entity to the same entity. And it's being used for all reporting. So reporting before had to be aggregated across multiple systems. You can imagine like 40 different spreadsheets. But now you'd pull one, and instead of using all the IDs, you would do all analytics on the new IDs, right? So this was the initial usage. This was entity resolution. It was an very interesting project, in part because the data quality was so poor. It was a lot more complicated than it should have been, right? If we had perfect records. So there were lots of problems with things like names misspelled and addresses misspelled and wrong things being ended up in the wrong columns. So there was a lot of work being done, not just cleaning, but we had to build more sophisticated models that would kind of combine, aggregate all the potential similarity scores, accounting for the things that there could be really bad mistakes in there, and try to build a resolution system. So it was a classification system first that would classify whether a pair of records are, how similar they are, whether they are matched or not, according to our end user. And for finance, it would be a different model. And then after that, on top of that, there was a clustering algorithm that would group all of these dependent on their distances. So you would have groups of the entities, right, of the records that would belong to the same entity. And at first it started, just as I said, it was a Jupyter notebook that we would run once in a while on a small subset of data. And we have a lot of records. It was, hundreds of thousands of records. So going by hand and doing this is impossible. It takes years. They actually started doing that a decade ago. They tried to do this manually. It took them several years where they did in a small chunk of data, and then they stopped there because it was impossible. So
yeah. Several decades ago, I used to work with patent data, and I was always stunned by the number of inventors who don't know how to spell the city that they live in and running into the same challenges. I guess I'm curious in terms of the value that comes from this, in the sense of, I mean, I can imagine that being able to do this more effectively enables you to go in and have a better overview of sourcing and recognize when actually this is going to the same suppliers and be able to negotiate better prices from them, for example, or be able to identify when you've got supply chain risks because it's too consolidated on a particular supplier. But it sounds like there's also another element of this, which is just somebody had to do this manually as part of ongoing reporting previously, and it was a pain and the data was poor and all of those kind of things. So there's a cost and efficiency element to going in after a use case like this as well. Was it more on one side or the other?
It's actually both. So the need, our actual original problem was that there was no visibility, exactly what you said, single sourcing or too many different sources for the same material, right? Consolidation of vendor base, really having an understanding what your vendor base is like. And it was very challenging. And so analysts were struggling with it. You would have small subsections, right? Domains, so somebody would be focused on just one group of vendors because that's already overwhelming. But overall picture was very difficult to put in. And even for the smaller subsets of this data, it was still too big of a challenge for an individual to be able to do this by hand. It took one person, like I said, we had maybe ended up harmonizing maybe 1,000 different records where we're in hundreds, closer to 500,000 of different records that we have, and they managed to deal with just 1,000. So clearly, manually, that effort would not ever succeed. It will take years and years for many people. So automation was a big part of it. That was the process. So we tried to automate the process. But the goal was not necessarily build 100%. So we could have continued to improve. But what the end users really needed is they needed help with recommendations, or at least initially, right? Because even though we build internally, our internal test results for the models were higher than 90%, 93% accuracy, which is really high. A typical MDM is around 70% accurate. So we were, significantly better, but still it requires validation because some important decisions are being made in that. So the validation was by hand. When we built the first prototype of the system, the model itself was already built, but how do you produce the output? So instead of having an application, instead of putting in the database, it was a spreadsheet. You would send somebody a spreadsheet with recommendations, and they can very easy, and you would design it in such a way that it has all the relevant information for the end user to be able to validate very quickly. Right. So that was the beauty. That was the part that's not ML related, not AI related, but how do you produce your output for the end user is so important because it made it useful for them rather than you just delivered a great model that works in principle. You delivered a solution that works for the specific end user.
At the end of the day, it's always the right information to the right person at the right time in the right format that they can actually take the right action off of it. And it's amazing how that was true decades and decades ago, and it still is true today, and we still struggle with it.
Yeah.
I guess I'm always curious because when I was an industry analyst at Forrester, I was always surprised at how few success stories I saw in the manufacturing space. There would be some, but it wasn't anywhere near as much as I was seeing in other horizontals and other verticals. And that always struck me as weird. I mean, this is a data-rich environment. Data is generated all over the place. It should be a target-rich environment as well. But I've always speculated as to why I don't hear more success stories. And I was wondering whether or not one of them is the culture side of things. This is, after all, a place which has been led by operations research engineers or operations engineers who are trained in Six Sigma methodologies, which are looking at trying to detect faults that are a tiny, tiny fraction of what we would be comfortable with when it comes to predictive accuracy on a machine learning model. So I guess I'm wondering whether or not, is there a cultural challenge in terms of bridging that mindset of, well, no, you shouldn't be thinking Six Sigma. You should be thinking, how can I improve on what our existing process, on what our existing decision-making process is? Or is it more really on the data side that, yes, it's a data-rich environment, data is generated, but it's so messy, it's so difficult to consolidate, harmonize, and work with that there's actually a fairly big barrier to entry in terms of being able to go in and tackle that low-hanging fruit?
I think it's more of the second. So in terms of a culture, it's true. Manufacturing, especially in some industry like chemical, pharmaceuticals, semiconductor, and semiconductor is probably one of the more stringent ones. Surprisingly, I think they're more stringent than pharma. I think Six Sigma came more from there, right? One fault per million. But the culture of really paying attention to details, recording everything, being very data savvy, it does exist. But it's, on the other hand, it becomes a hindrance to machine learning kind of projects because the question is, well, we already have statistical process control. Why are you bothering with predictive process control? Why is there a need? And frankly, the honest answer is you're right. We should not jump straight from no process control whatsoever, or like a set of conditions that you always run but you don't pay attention to, directly to predictive modeling. It doesn't make any sense because even if you did have a really good model, which is extremely challenging, I'll get into the details a little bit later, Even if you do that, if your operations are not used to operating in the best of, the Lean Six Sigma, right, really statistical process control, what's going to change their mind if you have a predictive model for them, unless you are willing to close the loop completely and take the operators out of the picture, which is not going to happen for a long time. I mean, we all know about the story of the self-driving cars, right? It was always around the corner. And I honestly believe that they're very close because in vast majority of cases, you would make the right decision. But it's the problem with those outliers that the consequences is so bad that you just cannot allow it without human intervention, right? So this is where the gap is that the fact that this one small, the risk of critical failure, catastrophic failure, same for chemical process control. For us, if we have a predictive model in a closed loop, so it actually controls the equipment, and you have prediction that can lead to catastrophic results, you literally could blow up the building, right? And hopefully that doesn't happen. So that's why I see human in the loop being there for a long, long time. You have to do lots and lots of trust to be able to take the human out of the loop.
Yes. Well, it's also possible to run those statistical control process methods in parallel to your machine learning model, so that you can get a second opinion, another form of reliability, or another form of control on this, in addition to presumably also having a human in the loop. So now you have additional levels of redundancy and oversight on what is happening.
Right. And this is kind of what we do. But the resistance, again, like, what's the value? If we already have something that's pretty good, so the value comes in two places. One is if you already have a really good statistical process control in place and you have good operations to execute on this process control. The next part is, what do you do if you want to squeeze that 2% out of the yield? And this is where statistical process control is too limited. So then you would have to go for something more advanced. And in those cases, which are not as common as you would think, so in those cases, you would probably have enough data, very good data, to allow you to build a good predictive model. The problem is with majority of the use cases, as you mentioned, we do collect enormous amounts of information. Devices, we can have thousands of the devices on a system, on a reactor. And you would generate data every, 50, 10 milliseconds. A data point for each one of these sensors. So that's a lot of data. But the problem is there's all other kinds of data that is not necessarily being logged or connected very well, because the systems, even the simplest chemical process, is still incredibly complex in terms of what's happening. You have to connect everything happens to upstream. If there is an operator, you need to understand, why did they just slow down the process today versus yesterday? And it could be because they are too tired, or they want to time it so the second shift is going to take over part of their job and they're not going to do it. It's not logged anywhere. And these are silly examples, of course, but you can imagine there is a lot of additional information out there that's outside of the sensors, that's not being captured. So what happens with the sensor data, even though you have tons and tons of it, when you try to do a predictive model and then the data is too noisy in terms of you do not have some of the signals captured. So what you believe are signals in reality is just noise, because we have incomplete data sets. So we're not capturing everything that we need to be able to represent the physical reality of what was happening in the reactor. That's one of the big challenges in the manufacturing space, because of so much complexity and every little detail matters.
Is that something that you find that you're able to tackle in the project, so that there is a component of a lot of these projects which is to go out and find and capture additional data, or identify other places where that data which has signal has existed, but either hasn't, as you say, hasn't been logged, it's been thrown away, or it wasn't visible, but was there? Or does it tend to be, no, we kind of have to work with the data that we have, and yes, we can explore for it, but the ability to change the data collection process, it's very difficult in any organization. I guess I'm curious whether or not it's any easier on the manufacturing side.
Still hard, but again, if we take things from the beginning of project, let's just say that we're going to a plant and we want to improve a specific process. Typically what happens is we do a lot of exploratory analysis on this, and some of the insights could be used right away. It doesn't have to be in this. We could use machine learning models, for example, to understand feature importances for things like that, right? Or statistical methods to understand feature importance, like what is important. We can deliver that fairly quickly. So the changes on the floor can happen without us having to have a fully blown predictive model. Like our predictive model we might not, with the data set that we have, we might never be able to get a high accuracy enough model to be fully useful. But we do see some trends that this particular knob is really critical to the process. And we observe that when the process goes well, this knob is at this setting, at setting A, and if something goes bad, at setting B, right? So that's right away. That's very quick return. After that, we go back to Six Sigma and say, okay, let's do design of experiments. We don't have the right data. Let's generate it in a controlled way. So we typically, in the last couple of years, we started doing this after initial analysis, when we realized that we can't really do much. We start doing design of experiments so we can collect the data to be able to build, to generate afterwards decent enough predictive models. The last resort is if we say, you know what, this is too difficult, but besides giving you more optimal set points from our initial analysis, maybe we can tell you, is it going to be helpful to you if we tell you, if to the operator or for process engineer, if we tell you whether the process is going in the right direction or the wrong direction with a given set of what's happening right now in the equipment? That's a classification. That's a much easier problem to solve than a regression when you have to know exactly what value needs to be at for the process control, right? So we try to still, even if we can't find the full solution that the end user is looking for, we still try to find partial solutions. And when we do that, it again goes back to building trust. So when we leave a plant and we say, okay, we're giving you some model right now, start collecting this data and collect it for a year or for 6 months. We'll come back and we'll do something better for you after, because right now we just cannot do anything more. And there is a lot more willingness from our plants, from our operators, process engineers, to put the extra time to record the data, to do additional design of experiments. It's a lot of it is relationships with our end users, not just machine learning, not just data itself, it's relationships.
Well, I mean, I'm struck by the fact that it's very popular these days to throw out the word digital twin in Jensen's keynote over at NVIDIA GTC over and over and over again. And that sounds absolutely wonderful. And it also sounds like a boatload of time, effort, and investment to go in and create something that's going to be a realistic simulation or facsimile of an existing process. I mean, if it was going to happen anywhere, I would assume it would happen in manufacturing. But I'm imagining that you rarely have that luxury. And instead, this is more about, well, so what can we do in terms of simulating a machine, simulating a process, and doing that kind of quickly and generating the data that way, versus thinking of something which is a more high fidelity digital twin? Or no, is it actually possible to go in and create a realistic enough simulation of a particular process that we can then leverage the data from that in order to do interesting things and potentially train models off of?
Yeah, it's a very, very interesting question, and there is no easy direct answer to that, because it's in reality it's both. So digital twins for complex chemical processes are very complicated to build, especially if you're just going to try to rely on machine learning. Typically, what we see is that first principles trump in performance. It's pure machine learning. We started looking into things like physics-informed solutions. So it's a combination of first principles and machine learning, but it's still a challenge. And the reason why, because of the complexity. Like I said, even the simplest process could have thousands of sensors. And usually it's not just one process. It feeds into a line, and line contains multiple processes. So they're all connected to each other. One feeds into another, and so on. Digital twins do exist. The problem that we've encountered, it takes a really long time to build, to collect all of the data, to really build an application. So if we find that the production line is really important, and we really need to squeeze out the as much as we can out of it in terms of the yield or throughput, it would be worthwhile to do that. But it's very often it's not low enough hanging fruit. There are other things that we can do much quicker that would give us immediate return, and a pretty significant return, because we're not quite there yet. With this said, there are out there the third-party digital twin solutions that we have been using. Funny enough, in the end, a lot of them still rely on first principles, and maybe there are neural networks somewhere in there, but in the end, it's always linear regression.
Well, I mean, linear regression, you can do amazing things with it, and it always has that benefit of being very explainable to an end user. And yes, you might have to get really creative in terms of interactions and other things like that if you want to get to map or to replicate or identify very complex patterns, but usually eventually you can. But so is the regression models largely because of the explainability or the fact that it's time series data, or are there other things that make it still the workhorse?
Explainability is a very big part of it, because Imagine a black box solution. Let's say you have a very accurate black box solution, but what you really need is not a black box solution. You need to know what needs to be changed, what parameter needs to be changed, and by how much and why. Even though there have been advances in explainability, right, of neural networks for sure, it's still not as simple to explain to the operator over the shot plot versus I have a coefficient of a linear regression, right? And this is why you need to increase this by 1.5 times and not 3 times, right? So yes, explainability is a very, very big part of it.
Well, it almost sounds like it's not explainability, but actionability. The explainability tells you what you should do about it. Identifying that there's a problem with it, great. You've told, it's sort of like being had a warning that the risk to the world safety is very high. Great. So what do I do other than just be very anxious and nervous about this and maybe buy gold?
Yep.
Sounds like a similar thing here.
Well, absolutely. It's both. It's both. Yeah, actionability for sure, but also explainability. So, like I said, we don't have any closed, we're not ready. I don't think industry-wise, I think there are very few solutions. I mean, I could be wrong, but I very doubt that there are many very closed loops, like fully closed loop solutions with ML products for manufacturing just yet. Maybe in some point in the future. So if you have a human in the loop, the human in the end has to make a decision. So that if they don't understand why you recommended for them to proceed in a certain way, it's very unlikely they're going to make that. And they're going to say, you know what, who are you? Especially people who are not familiar with machine learning or even statistics. There's little trust. So it has to be easily explainable and obviously actionable, as we mentioned, right? So just not just that I know that something is going to happen, like what do I do about it, right? And linear regressions are very easy to work with for both explainability and actionability, because you know exactly what needs to be turned and you know exactly why.
Oh, indeed. Well, it sounds like there are a bunch of different things that are all happening simultaneously. So when we're, in terms of being able to deliver value quickly or being able to drive trust, but also be able to minimize risk, it sounds like the same thing that you would be doing in order to drive value quickly. For example, doing this with human in the loop and augmenting an existing decision, delivering value in stages is exactly the same thing that you would do in order to drive trust, which would also be exactly the same thing that you would do in order to mitigate a lot of risks. So it sounds like, well, it's not an either or here. It's not an either I can deliver value quickly or I can build trust or I can mitigate risk. It's the, well, I have to do all three of those simultaneously or I'm not going to be able to do any of them. Or is that true? Or is it the, well, it depends on the project. Some of them, we don't have to worry, or sometimes they can be in conflict and sometimes you need all three.
I think it's a very astute point. It is all three, and you have to, because you have to build applications not just for high performance, but for their adaptability, right? So you always have to have the trust, and you do have to deliver it fast because it's not going to be adapted. That ship has sailed, right? That they would say, it's too late. This is not a problem for me anymore. I'm already finished by hand, right? For a lot of things. So I think naturally for us, because we have all these three kind of requirements in general, the way we work, the way that we try to split up the problem, the way that we focus on the problem rather than the solution. And for us, AI, machine learning, analytics, it doesn't really matter. It's a tool in a toolbox because we're solving a specific problem, right? So we're very problem focused and working with the customer and always addressing their needs and always trying to build their trust and having them engage in our team. That flew naturally out of our previous, mistakes where we did build in several years back, we built great optimization for like capacity margin optimization tool. It was great. It was a very awesome model. The problem is this is not what the end user really asks for. And even though they could use it, it took us a year to try to convince them that yes, you could use it. It's really useful to you. But in the end, we had to rebuild everything almost from scratch. I mean, the model still sits there by itself. It waits to be plugged in into the rest of the work stream. But because we approached it backwards, starting from a great model that somebody higher up said, you know what, this would be really great if we had a model for this. And we did it, and it was pretty good. But the end user who had to use this model said, well, I don't know what to do with this, right? So we learned our lesson, and this is why we started focusing on interaction with the user, on building trust with the user, on addressing their needs. We put in customer first. You hear it everywhere, customer first, but really, it really helps when you design a solution for the customer. And in this case, we're a little bit lucky because we're building for internal customers and our user base is small. So we know who to build. We don't have the problems that you have this general population that you're trying to build an AI tools platform for. It's much harder to address everybody else's needs because the needs vary so much. For us, it's very focused. We know exactly what the needs are, and all we have to do is communicate well enough to understand those needs and build a solution for the needs.
One thing that feels different here, or special here, is that it almost sounds like you are minimizing the amount of change that your end user is going to need to do and making that very explicit. Or, well, implicit, but making that a big focus of the project. It's we want to give them as much bang for their buck for the minimal amount of change in how they're doing their existing process, which is not usually how we approach things from generally in data science. Usually we don't even bother thinking about, well, what is the existing process that folks go through? It sounds like, because everybody says that, well, we need to understand the customer and very close to the customer. But here, it sounds like a key thing is understanding just how difficult it is for that customer to change an existing process. And so to the degree that you can minimize that amount, the more likely the success of the project is. But it sounds like also potentially also the lower the risk of the project is, because you don't have to change as much. If you change a lot of things simultaneously, who knows what's going to happen if we are making smaller, more defined tweaks, but using the existing process and the existing controls that are in the process, the likelihood of something going wrong is much smaller.
Absolutely. And it doesn't mean that we're going to stop at these little incremental changes. It's just over the years when you start looking, oh, what have I changed over the last several years? It could be a lot. You did it in small steps, so it didn't seem like such an abrupt, big change, but you managed to modify the process. And it's funny, we're like having a discussion right now. We were thinking of using generative AI to build like a chatbot that would help our operators, process engineers with manuals. So transform the way that they would interact with manuals, because our manuals would tell you exactly what needs to be done at every step of the process or in every possibility, right? Usually it's a document and it's some structured are better than others and some language is clearer than others. And the first use case is, well, let's just go for a chatbot that's going to transform. We just query, take all of this knowledge, right? Build a RAG system and have a chatbot that will allow you to interact it. But the counter to that was, well, our operators are not really experienced with that. It's unlikely they're going to do that. They just want they just want a standard document that has the same format and has the same language and the same order of things. And yes, maybe, and it's probably a simpler thing to do. You probably can work with one document at a time and you fix it. And maybe with the help of generative AI, you take the input and you say, I need a different format, please produce an output for me. Much easier use case. So probably we'll take up that instead of trying to build a chatbot from scratch that would transform the way the operators work. But once they're used to it, once they see the value, because we'll build some features where there will be some chatbot, but maybe it will still produce the document for them. Or maybe it will be a combination of a bot plus a document. But on that, you will drive adoption. Adoption is always a challenge, especially the less AI, ML literacy there is, the harder the adoption is for these tools because people are distrustful. Some are scared that, AI is going to come to kill us all. Some just don't understand. Like they're really genuinely surprised at the capabilities. I'm like, oh my God, this is revolution. It's a light bulb. I had no idea. But everybody is resistant to change. It's part of our human nature. So if you can make the transmission smoother for them, if you acknowledge the challenges that they're facing right now and show them step by step how they're going to operate in the future, it certainly helps. So it's the product owners or the project lead's job to really make sure that the change management does not lag behind this great model that was developed and nobody has to, we don't know where to plug it in.
Indeed. Well, so thinking back as to what the best practices are, it sounds like best practices to a certain extent is to align how you deliver value with how you're minimizing risk, and what you're doing on one dimension should be another. So whether that be leveraging humans in the loop, whether it be delivering values in stages, going in and minimizing the amount of process redesign that you're imposing on your end users. Those sound like they're key ones. Other ones sound like being able to go in and really understand your data and where signal lives, and change any work that you can put in going in and increasing your ability to capture that signal, sounds like that would be valuable. Are those the best practices? Are there other best practices that you would add to that list?
Be very data centric. So if you're trying to automate a process using machine learning, right? Machine learning in the end is just pattern. Right now, they're all pattern recognition systems. Anything from linear regression to all of these large LLMs, they're still pattern recognition systems. So if your pattern doesn't exist in the data, you're not going to capture it no matter how much data you have. So focus on the pattern, and the more important the pattern is that you're trying to capture, the more prominent it should be in your data. So be very mindful when you design your training data sets. I think that's critical for us. It led to a lot of success, but when we really handpicking what data we wanted to, for automation tasks mostly, right? Split up complex projects into smaller ones and try to deliver. Can my initial preliminary analysis or exploratory analysis, is this useful to you? Can I give you some insights into the data? That already builds trust. So think of any small part in the process of developing machine learning models, AI systems, what along the way can be useful to your end user. It doesn't have to be the full product. That's also, we found it was very useful. To speed things up, we didn't discuss this, but I think it's worthwhile mentioning, we tried to build reusable components. So if we access different systems in a certain way, we want to make sure that the way we access it is standardized, the way the login is standardized, the validation is standardized. So we try to pre-build our internal packages that would be reusable. So we spent some effort into building our own internal packages for the way we do things for our data pipelines or whatever it is. So we focus on that as well, making these digital assets for ourselves.
Alex, thank you very, very much for sharing all of your thoughts on this. If folks want to get in touch with you and reach out, direct them to LinkedIn or other ways in which they can keep in touch with you.
Yeah, LinkedIn sounds great. Yeah, not sure I can company email, but LinkedIn is a perfect place to reach out to me. Yes.
Wonderful. Alex, thank you so much for your time.
Thank you, Gil. It was a pleasure being here, and thank you, Amonur, for the invitation. Take care.
Thank you. You've been listening to Data Science Leaders from Domino Data Lab. If you found our discussion insightful, be sure to subscribe to never miss an episode. Your support helps us deliver cutting-edge content and keep the data science community informed and inspired. We appreciate every review. Until next time.